Hi, I'm Lauren, an OpenSciEd teacher and facilitator, and we are here to talk through lesson 18 today, the final lesson in our thermal energy unit. So let's get started. First, let's think about how we got here. During lesson 17, we built, tested, and reflected on a second cup design. We figured out that certain materials helped cups perform better on certain tests. In this lesson, lesson 18, we are ready to generalize our model about energy transfer and apply our model to a related phenomenon. In this lesson, we are returning to our unit driving question: how can containers keep stuff from warming up or from cooling down? Here's our lesson at a glance. Lesson 18 is the final lesson of this unit, and it is a 3-day putting the pieces together lesson. It requires about 45 minutes of preparation across the 3 days. You will want to have previous class consensus models posted around the room. Here's our learning plan snapshot for lesson 18. On day 1 and the start of day 2, we'll analyze our cold cup challenge data and work on a proposed redesign before creating a generalized consensus model. We'll then start thinking about how to modify our model to maximize energy transfer between systems. So we summarize our understanding about what we figured out about rate of energy transfer. First, that the rate between two substances either speeds up or slows down depending on the number of particle collisions. And second, that the rate of energy transfer between a substance and light either speeds up or slows down depending on how much light is absorbed. Students will work on applying this to a related phenomenon for both home learning and the start of day 2. Then in the next chunk of the lesson, on day 2, students will also apply their understanding through an assessment task, looking at disaster blanket designs. In the final chunk of the lesson, on day 3, we'll revisit our driving question board and then reflect on all of our experiences throughout the unit. We're able to celebrate what we figured out and reflect on our sense-making process. In lesson 18, we figure out and synthesize a number of things about the rate of energy transfer. We figure out that the rate of energy transfer between two substances speeds up or slows down depending on the number of particle collisions. That the rate of energy transfer between a substance and light speeds up or slows down depending upon how much light is absorbed by the substance. And that the amount of matter in a substance affects the rate of energy transfer and also how much energy is needed to increase the substance's temperature. Here are some of the key moments of lesson 18. In part 3, we use our analysis of cold cup challenge data to design the ultimate cold cup together. We'll meet in a scientist circle to do this. The students come to a final consensus about the key design features and the science ideas that support them. This serves as a conclusion to our anchoring phenomenon, so it provides closure for the students, but it's also a great place to navigate towards broadening our understanding. So, okay, we have figured out so much about how energy transfer happens and how to slow it down. So, how could we use this to explain other systems? That leads us into a discussion about related phenomena. So in part 6, students apply their models to explain related phenomena. This is a great opportunity to connect back to the list of related phenomena from the start of the unit. Students also have the opportunity to use their brainstorm from day 1's homework assignment as a list of related phenomena to focus on here too. This is also an additional assessment opportunity if you choose to make it so. You could extend this and have the students draw explanatory models for their related phenomenon. That can serve as an assessment or could also serve as a review of those key science ideas. Part 7, though, does have a summative assessment for our students. This is where they're demonstrating understanding on a transfer task. It's a related phenomenon around disaster blanket design. It's important to know on this assessment task that the students do not have, there's no one right answer for the blanket choice that they pick. Instead, the students have to consider different trade-offs and make an argument based on the data they have provided. I think it's important to let the students know this up front. There is not one right answer, but you have to defend your choice using data. This is a challenging transfer task assessment. Some modifications to consider when you're using this with your students are to possibly talk through it with your class or let the small groups talk through it first before attempting it. Another thing to consider is to mark up the data tables together. You could chunk portions of the assessment for the students. We also found it helpful to have the students actually have small group discussions or talk about it as a class, thinking through the pros and cons of different choices first before they make an individual decision. That small group discussion time can help the students to make a stronger argument. There are also opportunities to place sentence starters in to help with the explanation portions of this assessment. There is an answer key with suggested responses in the folder of materials. We find it helpful to use that to help shape not only what we're looking for, but also to provide guidance for what sentence starters we might want to use. The final part of this lesson in part 11 is a quick write for the students to reflect. It is so important to have the students take time to reflect on this growth during this unit. For example, very few, if any, students probably included particle level explanations in their initial model. This is one of my favorite things to do at the end of a unit, to go back and look where we started and see just how much we figured out. It is so powerful for the students to see how their ideas have changed. The unit materials include a slide with prompts for a quick write. Some possible things to also consider: possibly extending this to a longer Google form or a longer reflection that includes norms or class-specific questions, including an opportunity to make a graffiti board to celebrate what we figured out, keep that posted in the classroom, or maybe a quick write, but follow it with inside-outside circle sharing so the students can share their reflections or what they noticed about their growth. Whatever works best for your class and your specific students is great. What's important here is giving the students the chance to think back on their process and their progress and their growth throughout this unit. There are limited material management needs in this lesson. There are also no additional words added in this lesson. It is helpful in this lesson to continue to have our previous consensus models displayed around the room. The students worked together on day 2 to create a generalized model of energy transfer, and it's helpful to save that and also the consensus model showing particle collisions for future units. That is the end of lesson 18 and also the end of our thermal energy unit. The students will use their understanding of particles and energy transfer in the next unit, the weather, climbing, and water cycling 6.3 unit. So it's great to see them build on what they figured out here and apply it to a new phenomenon. Be sure to check out the 6.3 on-demand videos for suggestions for these lessons.